Hey everyone, today's lesson from Unit 7 is notes number 6, the sine and cosine functions. So we're going to continue our study of trigonometry today. So as you recall, the other day we talked about our angle, and we'll work with angle A today, and then we labeled the sides in reference to that angle. Well, the 13 would be the hypotenuse no matter which angle we are looking at. But for that angle A, which is 26 degrees, x is the opposite side, or opposite leg, and y represents the adjacent side, or adjacent leg. And so suppose we wanted to find the lengths of the legs, x and y, in the triangle above. Could we use the tangent ratio? Well, let's check it out. We could try. We could say the tangent of 26 is equal to the opposite side over the adjacent side. But notice how that gives you an equation with two variables. And just a little reminder, tangent is always equal to opposite over adjacent. All right, if we worked with the other angle, 64 degrees, say in the upper right-hand corner, we can say the tangent of 64 is equal to y over x, because y would be the opposite side and x would be the adjacent side. So the short answer is no, we can't use the tangent ratio. There are too many variables in our equations. So that leads us to two new trig equations, and they are the sine ratio and the cosine ratio. The sine ratio is equal to the ratio of the opposite leg, the length of that opposite leg, divided by the hypotenuse. And the cosine ratio is the length of the adjacent leg divided by the hypotenuse. And of course, for these two, we also have shorthand versions. They would be sine, not pronounced sin, but sine of A equals opposite over hypotenuse. And a quick way to remember that is to think SOH, S-O-H, sine is opposite over hypotenuse. And cosine could be abbreviated to COS, so please don't pronounce it cos, it's cosine of our angle A, and that's equal to the adjacent leg over the hypotenuse. And that would abbreviate to CAH. So we have a little saying that can be used to help you remember all three trig functions, and that is SO, CA, and then TOA. Remember, tangent was opposite over adjacent. So SO, CA, TOA. SO, CA, TOA. We use that to help you remember those three functions. Okay, similar to what we did for tangent, we're going to use the scientific calculator or trig table to evaluate each of the following. So if you press sine of 30 degrees on your calculator, you would see 0.5. Again, we're going to round to the nearest 10,000, which is 4 decimal places. For cosine of 45, it's equal to 0.7071. And finally, for the sine of 78 degrees, it's 0.9781. Okay. So now in example 2, it says find the values of x and y in the triangle at the top of the page, and we want to round to the nearest tenth. So we're looking for side lengths, and we're going to solve for one at a time. Obviously, we can't solve for two things simultaneously. So I want to work with my angle marked with the 26 degrees, so I'm going to label my sides accordingly. Across from the angle A, or 26 degree angle, I see side x, so that's the opposite side. Y represents the adjacent side, and 13 is our hypotenuse. So I'm going to choose to solve for x first, and I want to use the opposite side and the hypotenuse. Opposite and hypotenuse leads us to sine. So we would write the sine of 26 is equal to x over 13. Remember from our lesson on tangent that we want to treat this as a proportion. Put the sine of 26 over 1 and then cross multiply. X times 1 gives us x. We want to set it equal to 13 sine of 26. And please follow my advice and put that 13 out in front of your trig function. So you type in 13 sine 26 on your calculator, hit the equal key or enter, and it turns out to be 5.7 when rounded to the nearest 10. Okay, next we're going to solve for the 64-degree angle. So I'm going to mark it in red. For 64 degrees, we want to work with the side y and then the hypotenuse. So the y is actually opposite my 64-degree angle. So I can set this up as cosine of 64, sine of 64, excuse me. Is equal to y over 13. And again, we'll cross multiply. So y times 1 is y. And that's equal to 13 sine 64. And when you type in 13 sine of 64 in your calculator, you should get 11.7. Okay, you could have also used the 26-degree angle to find y as well. You would just have to use cosine of 26 is equal to y over 13. And when you cross multiply, you get y is equal to 13 cosine 26, and it would still be 11.7 for your final answer. So same answer using a different trig function. Alright, in example 3, we want to find the measure of angle A. We're going to round to the nearest integer. So you have to figure out first which trig function you want to use. So look at the given information, label your sides according to the relationship to angle A. 6 is the opposite side, and 14 is the hypotenuse. So opposite and hypotenuse will lead us to sine. So we want to say sine of angle A is equal to 6 over 14. Now remember how we used inverse tangent to find an angle? We're going to use inverse sine in this case. So we say A is equal to sine negative 1, that's your inverse sine, 6 divided by 14. And it's that inverse sign that tells the calculator to look up 6 divided by 14 and tell us which angle has that value for its sine. When you do that on the calculator, when you round to the nearest whole degree, you should have gotten 25 degrees. Okay, for example B, here's our angle A. I see that 17 is the hypotenuse, 15 is adjacent, so adjacent over hypotenuse leads us to cosine. So the full equation will be cosine of angle A is equal to 15 divided by 17. And again, we want to use the inverse function. So A is equal to cosine negative 1, 15 divided by 17. So type that into your calculator. Remember to use the second key, then cosine, and it rounds out to 28 degrees. All right, as always, good luck on your homework. If you need any extra help or another explanation, please come and see me.